Hello, welcome to Li Yan's presentation of the course Network Science and Application. My topic is economical network analysis based on complex networks. About the outline, first I will introduce the definition and the motivation of using complex networks in economical network analysis, and second, I will explain the network representation used in this project. And third, based on modularity, the network is clustered into different communities. And fourth, a ranking of the stocks based on eigenvector centrality is achieved. And the fifth, and then I will demo the programs, and the following will be the conclusion of this project, and then the references. About the economical network, the motivation is that the fluctuations of stock prices are not independent, but are highly intercoupled with strong correlations with the big business sectors and the industries to which the stocks belong. The usual approach involves a procedure of finding correlation between each pair of time series of stock prices and the subsequent procedure of constructing a network that connects the individual stocks based on the levels of correlation. The factors affecting the network stock network include economical environment, political news, tickers operation, and also the investor's strategy and skills. However, the factors can all be represented with a correlation matrix. About how we use correlation to represent this network. In this project, the historical data of the Nasdaq 100 stock market ranging from January 1st, 2007 to December 31st, 2011 is used. Without losing generality, the close price of the stocks is used, and the daily logarithmic profit rate of the stocks is used in calculating the correlation. The temporal correlation coefficient between the ith stock and the jth stock can be represented with the equation below, where the S sub I is the average profit rate of the stock during periods, and the SI multiplies Sj is the average of the multiplications of the profit rate of the stock and the stock during the same period. S sub I square is the average of the square of the average of the stock profit rate, and SI square is the square of the average profit rate of the stock. And in this page, the distribution of the correlation coefficients is presented. We can see that most of the correlation coefficients are positive, and the peak value is around 0.67, and this phenomenon will influence the threshold we used in later parts. As in this project, the interested correlations is mainly in relatively strong correlations between stocks. The correlation matrix storing the weights of the stock network is divided into two binary value adjacency matrices representing positive effect network and the negative effect network. And for positive correlations, we use the threshold of 0.5 to determine whether the element in the corresponding adjacency matrix should be 1 or 0. For a negative correlation matrix, we use the threshold of minus 0.1. And as for the clustering, we use modularity to cluster the stocks into communities. Modularity is a measure of the structure of the networks. It was designed to measure the strength of division of the network into modules. Through iteratively searching for the sub-communities, maximizing the modularity score, which is defined by the equation below, the network can be clustered into different communities. And as we have two matrices representing positive effects and the negative effect, we have two clustering results. The left side is the positive effect network clustering result. We can see that the network is the stocks are clustered into two communities, and in the right hand network, the network members are clustered into three communities. The connection between them is represented by the lines. In this project, I also used the eigenvector centrality to make a ranking of the stocks. Eigenvector centrality is a measure of the influence of a node in network. It assigns relative scores to all nodes in network based on the concept that connections to high-scoring nodes contribute more to the score of the node in question than equal connections to low-scoring nodes. And as eigenvector centrality represents the importance of each node in the network, extracting the top-ranked stocks from the positive effect network and the negative effect network can provide useful information for making trading strategies. Other centrality measures can also be incorporated to generate trading strategies, such as degree centrality, betweenness centrality, closeness centrality, and so forth. And in this page, the ranking the 10 stocks with the largest positive effects on other stocks are represented. We can see that the original point represents the most recent date, which is the December 31st, 2011, and compared with the starting date, which is the January 1st, 2007. The 10 stocks, all of the 10 stocks have a better performance than the overall performance of the market. However, the 10 stocks with the largest negative effects are shown in this figure. However, compared with the overall market performance, the 10 stocks, most of the 10 stocks have lower or equivalent performance since the starting date of this analysis date. And these two figures can provide some information for the investors to in defining which stocks should be held and which stocks should be sold out. And next, I'm gonna demo the my program. My program is based on the close price of the stocks. As we can see, it consists of several parts. The first is the calculation of the correlation, and then based on the threshold, we use the threshold to control the correlation coefficients we are interested in, and then I use eigenvector centrality to get the rank of the stocks, and then I get the top 10 ranked stocks to generate trading recommendations. And in this part, the results are plotted in several figures, and in this part, the clustering, iterative clustering, is done and shown in figures. The network structure is also will also be plotted in this part. As we can see, oh, sorry, the program is still running. We can see that the clustering results have been obtained and demonstrated in the command window. The positive correlation matrix network is divided into 2 clusters, and the negative correlation network is clustered into 3 clusters. Okay. The first figure is the distribution of the correlation coefficients of the stocks, and then in the second figure, the 10 stocks with the largest positive effect on other stocks are shown, and in the third figure, the 10 stocks with the largest negative effect on other stocks are shown. And these 2 figures can provide crucial information when generating trading strategies. And about the network structure, in this figure, the structure of the positive effect network is plotted. In the last figure, the structure of the negative effect network is plotted. As we can see, it is clustered into 3 communities. And as for the conclusion, the project is based on the weighted network generated from the correlation of the stocks from the Nasdaq 100 market. The stocks are ranked according to eigenvector centrality, and the stocks are clustered into several communities. The information given by the ranking is helpful for making trading strategies. The community structure also provides reliable segmentation of the network for possible prediction methods, such as neighbor learning or and so forth. And furthermore, since open price and the trading volume reflect more of the investor's subjective consideration, it is worth studying in future work. And here are the references I used for this presentation. And finally, thank you for watching this presentation.